everybody, welcome to Space Oddities. You are very welcome. If this is your first time here, you're even more welcome than you could possibly imagine. So thank you for being with us tonight. On a packed program tonight, I'm joined by some Space Oddities rabble. And we have Michael. How are you, Michael?
Okay, thank you. Very
Good.
well.
Roger?
Fine.
Good, as always.
Jonathan? As usual.
Hello there.
That sounded really creepy, Jonathan.
That gave me the shivers.
Yeah, is that a dirty bag you're wearing, by any chance?
Very good evening. Very good evening to you.
And last but not least, of course, we have Daz. How are you, Daz?
I'm lovely, thank you.
That's a matter of opinion, but there we are.
Yeah.
Okay. So
Still got me looks.
These guys are in the UK. I'm in Spain, hot and muggy Spain. We've been promised severe thunderstorms today. We got an orange warning for storms and rain, but it rained for 5 seconds, and that was about as much as it could muster. But anyway. Not to worry.
In Spain, is it? You say it's an orange warner? Is that in Seville?
Yes,
and it's going to rain oranges.
Yeah, it is.
Yeah.
It is. Just keep taking the tablets. You'll be fine. Okay. So,
I think that's the problem.
Yeah. Lovely to see you all. I'm just going to have a look in the chat, see who's kicking around tonight. Who have we got tonight? We've got looks like the usual suspects. We've got let's go up here. Steve, hi Steve. Derek, nice to see you. Well, to see you, nice. All the rest of it. Oh, didn't he do well? Michael, well, he's in two places at once as always. Matt, hello Matt, how are you? Who else we got? Kevin, nice to see you, Kev. Astronebulae, hello. And Matt says some familiar names here from Twitter. Yeah, these people get around. So Susan's there. Hi, Susan in Ireland. Hope your weather's okay. And Jerry. Oh God, we've got a full house tonight in terms of our regular viewers. Heidi, nice to see you, Heidi. Is Rachel there? Rachel seems to be there.
Yeah, Rachel's there. Yeah.
Oh, how's the baby? Hope you're all okay. And there we are. Now, just a couple of things before we get really stuck in. Tonight, Lou was going to be giving us a talk about the strange or potentially strange things that the sun is doing at the moment. We're going to have a good chat about the behavior of our nearest star, because it appears to be doing something a little unexpected and unusual. But unfortunately, Lou can't be with us tonight. And so we're going to keep that till he's back next week. So apologies for that if you were looking forward to that. But this is live YouTube, and these things happen. And the other thing we'd like to announce is that finally the Space Oddities merchandise is now available. If you look in the description of the video, there are links to the T-shirts and the hoodies. But we can go one better than that, because here we are. So if you want to rush ahead and get your T-shirt now, you can scan the QR code there, which will take you to the company that is selling this merchandise. So the T-shirts, which I'm sure you'll absolutely love, available in 9 colours. They cost £19, including postage and packing in the UK. That is, add £10 for foreign orders. And I'll just leave that up there for a few seconds in case you want to scan the code now. Made from the finest quality materials, obviously. And what else can we say about it? Well, just be the coolest person on your street to wear your very own Space Oddities merchandise. So sorry it's taken so long to sort this out, but we had to get it right. And we hope that you'll enjoy wearing the T-shirt. And of course, you must be prepared for paparazzi. You must be prepared to be mobbed when people see you wearing Space Oddities stuff. So, get yourself ready for that.
Hoping to get mine this week, I think.
Right, yeah. Great. And that's the T-shirt. As far as the hoodies go, there are the hoodies, the wonderful Space Oddities hoodies. You can have them in zipper or over the head style, and they are £35, including UK postage and packing again. And we really hope you're going to enjoy those. And it will be good to see people walking around in these.
Yeah. Didn't you say, Andy, there's a calendar on the back of the T-shirts?
Yes, it's completely blank in true Space Odyssey style. It says calendar on the back of the shirt, but there are no dates. So there we are. I'll leave that up there for a few seconds more in case anybody wants to scan the code.
I've ordered the hoodie as well.
Oh, you're getting a hoodie as well, are you, Michael?
Yeah.
So you're down with the kids.
Yeah, ready for the winter.
Yeah, oh, don't mention that, please. So there we are. So there are the T-shirts and the hoodies. We'll put those up again before the end of the show, so that you can have a chance. But as I say, all the details are in the description of tonight's video. So have a look there for the details. So that's that. Anything else we need to say? Not really. Just sit back, relax, and have some fun with us this afternoon or this evening.
I'll just say, Andy, if anyone's missed those QR codes, all they need to do is play the video back and then scan them.
Well, that's true. That's true enough. Yeah. Or they can simply click on the link in the description.
Exactly.
Which goes to exactly the same place, funnily enough. The wonders of technology, huh?
Yeah.
Okay, well, let's kick things off. We hope you're all well and enjoying your summers. We had a busy week on Space Oddities last week, didn't we? We had we were covering a few things live, and we covered the announcement of gravitational waves, the announcement about the neutrino Milky Way, and what else did we do last week? Did we do anything last week?
The live launch of Euclid.
Oh yes, of course, we covered the Euclid live launch. So many congratulations to the European Space Agency for putting that wonderful new space telescope. I was going to say into orbit, but of course it's not going to be in orbit. It's heading to L2 to keep the James Webb Space Telescope company. And it's going to be really a few years before we get the definitive science results from that. But we're going to get the first bit of data released in November, I think, didn't they say, Daz? I think it was.
Yeah, something like that at the end of the year.
Yeah, towards the end of the year, they're going to be releasing the first tranche of data. It won't mean much until the other data, which they'll accumulate later in the program, accompanies it, but at least we'll get to see some data. And these really will be high-resolution images because the Euclid telescope has got the resolution of the Hubble Space Telescope, but it's looking at a much wider area of sky. So there's some lovely images to look forward to later in the year. Congratulations too to SpaceX, because the launch of the Euclid telescope on the Falcon 9 went absolutely flawlessly, as we've come to expect from SpaceX. SpaceX are carrying on doing the preparatory work for their second orbital attempt at Boca Chica. I saw yesterday or the day before that the enormous steel plate that they're going to put under the rocket to avoid the inadvertent mining they did on the first orbital attempt. This is going to be a water-cooled steel plate, much acting like an upturned shower head to try and stop the immense power of those 33 Raptor rocket engines biting into the ground beneath the rocket. So that's going to come up, Elon time in another 2 months. I don't think it'll be much before the end of the year, because they're going to have to get the license from the FAA, and there are court cases pending over the near disaster that was last time. So anyway, we will see. Moving on, we're going to come straight away, as habit dictates, to the man with his finger on the pulse of the universe. And if not, we'll go to Roger. So how are you, Roger?
I'm fine, thank you.
Are you ready to enter into the fray?
Oh, I'm all frayed ready.
Okay, let's get this up on the screen for you then. There you go.
Okay, so here we go for the first full week of July, 3rd to the 9th. And first things first, here is the sun. I've got Sunday the 3rd, but it should be Monday the 3rd. So it was today, actually.
You bought a Space Oddities calendar, didn't you? Be honest.
Yeah.
It is
of course. As you can see, that big group is now heading off off the limb there, and we do have some more to view at the moment. So it's not going to be quite emptied yet. And this was the moon last night. It was getting right up to the full moon point, which was during the earlier hours of today.
Yeah.
So I've got those.
Beautiful image, Roger, as always.
Yeah, so that's good to know. And we were earlier on with a full moon, so by the end of the weekend, we'll be on to the last quarter. So things aren't looking too bad moon-wise.
No, but it's fairly predictable.
Yeah, it's the same each month.
Yeah.
So at the moment, I've got this for half past 10 during the evening, just to show the setting planets of Venus and Mars.
Yeah, Venus is still quite high in the sky here.
Yeah, I mean Mars will be at its highest in just a couple of days' time at the moment. So for this week, so we can still see it just about. But I
had to laugh, Roger. There was somebody on Facebook saying I was watching a bright star in the western sky last night. I think it was Venus. I was watching it, and then suddenly it disappeared. Does anybody know why? And I was thinking, could be cloud there.
Yeah.
Yes.
Anyway, so we've got the Milky Way core nicely visible now, and
yes,
the summer triangle quite nicely visible.
Yeah.
So that's all well and good. So things aren't looking too bad. But in the wee hours of the morning, I've got this set for 4 a.m. This is between Wednesday and Sunday, where we've got Jupiter and Saturn up.
Oh, at last! I've missed those two.
Yeah. Obviously, this year Saturn's still going to be quite low as opposed to Jupiter. Jupiter will be about twice the latitude, the height of Saturn in the night sky. But we'll obviously make the most of it while we can when that happens. And on Thursday, you can see here that the Moon and Saturn will be fairly close to each other, relatively speaking.
Yeah.
So,
and that's 4 a.m, you said.
And that's about 4 a.m. So just dark enough to see something, but it will obviously be getting quite bright fairly rapidly. So a little opportunity there for a quick picture.
Absolutely.
So there we go, and as you can see as it goes on. But this is an interesting picture that was released. And this was the latest one from the James Webb. Now the reason that we've got a dark disk there is because of the methane absorbing a lot of the light that the James Webb was using to photograph this image. But it gives you a very clear definition of the rings on here. We've got A, B, C, the Encke gap, the Cassini division, and the F ring as well. And due to the proximity of the moons, we've got 3 in the view as well. So
yeah, Dione, Enceladus, and Tethys. Look at that.
Lovely image. Absolutely amazing.
It's amazing how bright the rings of Saturn are in the infrared.
Yes, obviously we can't see any of the alleged spokes at this time of the year.
No, it's not quite into the spoke season, is it? Although I think that's starting soon. If I remember right.
Is it September that's usually visible, isn't it?
Yeah, I think so. Yeah.
Yeah, so that'd be an interesting event. Perhaps it might be able to fathom out the reason for it.
Yeah, I did see somebody asking on social media, if this is an infrared telescope and the rings of Saturn are made of ice, why is it so bright? Well, they may be made of ice, but that's still quite hot.
Ice. Yeah.
Yeah. Yeah. So that's why they're so bright.
It's all relative.
It's all relative.
Yeah.
Absolutely. As Einstein would say.
Yeah. It's cold out there, but of course, as we're looking at it in, is this near image,
Yes, it is.
Yes.
near
Yeah.
infrared. Yeah. So we're looking at it at well into the infrared, and of course, so that's why it's picking it out. Although those rings are freezing cold, they've still got enough heat to reflect back to the James Webb. So that's why we're seeing them. And it's not Roger said the planet looks dark because the methane's being absorbed most of the light and the heat.
That's right. That's right. Lovely image, though, isn't it?
So I thought
It is fantastic.
So I thought, as we had that from the James Webb, I thought we'd have a little look back at the other planets that the James Webb has captured. So we've got Jupiter, and as we can see, we've got the aurora in the north and in the south on this view.
Oh yeah, that's a nice image.
And
look how warm the red spot is.
Yeah,
absolutely. And then we've got Uranus. Yes. And all these ring planets that we have, and that's Neptune as well.
Yeah.
So, I thought
absolutely gorgeous, isn't it?
That makes a nice composition.
I remember the time when we only had one ring planet.
Yes.
Yeah.
Now they're everywhere.
I remember the time when you could say Uranus without everybody sniggering.
And I thought this was an interesting slide because of the James Webb celebrating a year of operations. There's some exoplanets that have been catalogued, and I've got distances there in Mars as well as AU in relative terms for these other two exoplanets. So one's only less than 500,000 miles away from the star, which is why it's only got an 11-hour orbital period.
That's crazy. That's crazy.
And the other one's a bit longer at 18 hours, but that's 1.35 million miles away. So still very very toasty.
And
so that's sort of like if it's 11 hours, that's sort of like 2 birthdays in one day for us.
Yeah, that's right.
Yeah, lots of presents.
Yeah.
You would have to sing happy birthday to you.
Twice.
Just think of the royalties.
Yeah. Okay, so shall we carry on with the next part, which would have been Rachel's gallery?
Yes.
Yes,
now,
please.
Roger has kindly volunteered to take over.
Oh, that's what it was it?
Yeah, I think that's what it was.
Okay.
Yeah.
After all the torturing.
We won't mention the Chinese burn we gave him.
No. But,
okay. Well, we do have a few images, not too many, but we have a few.
Roger's kindly volunteered to take over Rachel's gallery in her absence. So,
yes.
Rachel, I hope you're watching, and I hope you're holding up scorecards.
Right. Okay. So for the first one we do have is one from Kevin. We've got some processing here of what it is. It's another one of his absolute stunning solar images, and I shall now proceed to show you. He says, "Look at that!
Wow!
Oh, Kevin!
Wow!
What the hell? That's amazing!
Look at that twisting filament there. That's fantastic.
Yeah,
Kev, that's fantastic. God, you must be so proud of that one."
Mm. Now, I have seen a picture on social media of that filament off the surface as it extends beyond the edge there. So that's an interesting one to have a look at.
That is.
Mm.
That's immense. That filament.
Absolutely amazing. Right.
Well done, Kev. Thank you for sending that one in.
Amazing. Right. So our next one is from Jerry DeLay, and it is the Sadr region in Cygnus.
Oh, I don't know this one.
So, lots of interesting dust lanes and things in this image.
That's lovely. Look at that.
Very interesting.
The detail's amazing.
Yeah, lots of dust lanes and stuff there.
Yeah.
So that's provided a lot of interest.
Thank you so much, Jerry. That's brilliant.
Okay, so we'll go on to the next one. One from Sonia of the Moon with a lunar V and a lunar X. And no processing was done after she took it with her Google Pixel and a 10-inch Dob. There we go.
Oh, lovely.
Very nice.
Yeah, it's picked up the X absolutely perfect on there. And we can see the V quite well as well.
Yeah.
Although that does come into view slightly earlier than the X.
Yes. Yeah, she's got those perfectly, hasn't she?
Well
done, Sonia.
That's very good. Oh dear, it's me.
Oh no, not again.
Not another one. Well,
No.
I'm in charge of the gallery, so tough.
Ooh, fighting talk.
Extreme nepotism.
And another one of the Moon. And this was just a hint after the first quarter. So,
beautiful, Roger.
I've lost the lunar V and the X on there, but that came out quite clear, I thought. Yeah. So that is the conclusion of the gallery.
Thank you very much indeed, sir. That's pretty damn good. Well, thank you, viewers, for again your. Well, what can we say? Every time we look at your images, we're just absolutely astounded by how good you all are at taking those images. It's absolutely amazing. And as we keep saying time after time, a few years ago, this quality of images from amateur, if I might call you that, astrophotographers would have been absolutely unthinkable.
Yeah.
And it's not just the technology. It's people actually spending a lot of time and effort getting to know how to produce these images.
Yeah.
So it's big hats off to everybody from us, because we think you're truly amazing. If you would like to send us your images, please email them, 1 image per email, if you'll be so kind, to spaceodditieslive@gmail.com. And if you could put gallery entry as the subject of your email, that would be greatly appreciated, because in Rachel's absence, Roger's going to have to go through the mailbox and find them all. And if it's got gallery or gallery entry in the title, just makes life a lot easier. So there we are. So Rachel, if you're there, what did you think of Roger's gallery tonight? I think he did a fine job. So round of applause for Roger. Well done.
Hey.
Promising start, Roger.
Could do better.
Yeah, absolutely. So there we are.
There you go, fella. Yeah. There you go, Rog.
Only a tenner.
That's all it is. Have you, austerity.
Have you done a bank job recently, Jonathan? Because every time you appear on this show, you've always got handfuls of cash. I want to know what your secret is, or what you're doing to get that money.
He's printing them, isn't he? He's printing them.
Yeah. Still can't get it quite right, but then
no, absolutely. But there we are. Okay, so yes, Dr. Peter says, how does one send in images? And I'll just repeat it just in case you missed that. Please, 1 image per email. Email them to Space Oddities Live, obviously all one word, at gmail.com. Space Oddities Live at gmail.com. That's all you have to do. We'll do the rest. So
yeah, Rachel's popped it in the chat.
Right. Yes. Yeah. Oh, yes, she has. Thank you, Rachel, for doing that.
Yeah.
And there we are. No, Astronaut really said the ink's not dry on them yet. I wouldn't be at all surprised knowing it's dry. So there we are.
I think Ian's got the right idea as regards where that money's coming from.
Yeah, that's where it's going. Yeah, good point, Ian. Yeah, I would like to say a big thank you again to all of you who continually, week after week,
yes, thank you.
buy us coffee.
Very generous.
It's very generous of you. It enables us to keep going and pay the bills that we have to pay. We've got some lovely things coming up within the next few months. Don't want to say too much at the moment, but we're expanding, and we will keep you notified of what we're up to. We are getting there slowly. And we're really thrilled at the moment that we seem to be picking up subscribers to this channel at an accelerating rate, which is wonderful. But, with your T-shirts, you'll be spreading the word, and your hoodies. So let's hope we can get more people watching Space Oddities, because we like talking to people. That's what we do. Now, what else have we got coming up on today's show? Well, in Lou's absence, we've had to move things around a little bit. So Jonathan will be talking later with his usual Neo watch. Jonathan, did you get your favourite 3 space images together?
Because of the time it took to put the Tunguska event presentation together, you're going to have to wait another week.
Can we stand the suspense? That's the question. Yeah. Anyway, on Friday, it was the anniversary of the Tunguska event, and Jonathan will be telling us a little bit about that later. Also coming up today, I'm going to be talking about the 2 major astrophysics announcements last week to do with gravitational waves and neutrinos. And also, we've got a video coming up, which Steve Warbis has done for us. We're going to show that, and it's all about the summer triangle, and astronomers will be familiar with that. And thank you for doing that, Steve. We're looking forward to seeing that. Just before we get around to that, we're going to go over to Michael. Now, as you may be aware, last week we were meant to be having the astronaut Scott Poteet on the show for a chat. Scott is he's the pilot of the upcoming Polaris Dawn mission, the first in a series of so-called Polaris missions in conjunction with SpaceX. Scott was, unfortunately, because of a family bereavement, unable to join us last week. We are going to get him back within a few weeks. But in the meantime, just to lay the groundwork for that, if you like, Michael's going to tell us all about exactly what the Polaris program is, because it's a fascinating set of missions, all in a good cause to raise money for St. Jude's Children's Cancer Hospital. So, Michael.
Yeah. Okay. Thanks very much, Andy. Yeah. Welcome, everybody. I'd like to talk to you about the Polaris program, as Andy said. And this is a commercial spaceflight program consisting of up to 3 space missions, beginning with Polaris Dawn, hopefully before the end of the year. I'll just go to the next slide. Yeah, Polaris program is a commercial spaceflight program funded by billionaire Jared Isaacman. Jared is a pilot. He's a billionaire. He runs a company called Shift for Payments. I believe it's similar to PayPal, and that's how he's made his money. And he does a lot of donations to charity, especially the St. Jude's Children's Hospital in America. And they've already raised, I believe, billions of dollars for that organisation. Jared, this will be Jared's second space flight. You may remember back in 2021, I believe it was the Inspiration 4 mission, which was the first ever. I believe that was the first ever commercial space flight, actually paid for by Isaacman. Again with a SpaceX Dragon space capsule. So go to the next slide. Just want to basically put things right. That this is the Polaris program has got nothing. Some of you may remember this particular project in the 60s and 70s. It was also used as a name for the US Air Force ballistic missile in the 60s, which was a submarine launched intercontinental ballistic missile. So nothing to do with that. That's confined to history now. So, okay, let's go on to the next one. The actual name comes from Polaris, the actual star of the same name, and the actual name of the program comes from that. Some of you may know that Polaris itself is a system of 3 stars. You've got Polaris A, Polaris AB, and Polaris B. And as there are 3 missions in the Polaris program, That's where they derived the name from. So there's just a map showing Polaris. Sure, all of you know about this anyway, but just a bit of background on that. So the missions, up to 3 human spaceflight missions that will demonstrate new technologies, conduct extensive research, and ultimately culminate in the first flight of SpaceX Starship with humans on board. There's no date's been set for this yet. Obviously, they're still working on the Starship, so we don't know how much longer that will be just yet. But okay, so Polaris Dawn will be launched no earlier than 4th quarter of 2023 on a Falcon 9 from Launch Complex 39A at Kennedy Space Center. The Polaris Dawn crew will spend up to 5 days in orbit, and they'll fly higher than any Dragon mission to date, endeavouring to reach the highest Earth orbit ever flown, even higher, much higher than the Apollo capsules, apart from those that went to the moon, of course. Okay, so the crew, Jared Isaacman, I've already mentioned, he's the commander. He's actually paid for all of this to go ahead, and that's why he's now the commander of the mission, and as he was the commander of the Inspiration 4 mission. Scott Batiste, as Andy said earlier, that we should have had last week on the show. He's the mission pilot of the mission, and Scott is a very experienced US Air Force pilot, trainer, and he's done quite a lot in the US Air Force, for more than 20 years, I believe. So that's the first two, and the second two are Sarah Gillis, who's the mission specialist, and Anna Menon, who's the mission specialist and a medical officer. Just one note about Anna Menon. Her husband is Anil Menon, who was selected by as an astronaut by NASA in the last intake of candidates. And so it looks like there might be a bit of rivalry, because Anna Menon, Anna will most likely go into space before her husband does. So a bit of yeah. Yeah, so
I wonder what they talk about when they get home.
Yeah, exactly.
Who said they're talking?
Yeah.
So that's just a bit of background there for you. Okay, one of the biggest things about this first mission is it's going to have the first commercial spacewalk take place, and it's going to take place approximately 700 kilometers above the Earth. It will be the first ever commercial EVA with the SpaceX design and EVA spacesuits, and they're an upgrade from the current intervehicular suits that they use at the moment. So that will be a spacewalk. I believe it's going to be 2 people. 2 others will stay in the capsule, but also because there's no airlock as such, the whole capsule will have to be depressurized to make this happen. So effectively, the whole crew will be subject to the conditions of the environment around them. So that'd be quite interesting to do. So okay. High altitude. The mission will take advantage of Falcon 9 and Dragon's maximum performance, flying higher than any Dragon mission to date, to reach the highest ever Earth orbit. And because of that, the booster for the Falcon 9 will not be recovered on the drone ship, as it usually is at the moment. So they'll actually expend the booster for that particular mission, because the height needed to get that altitude. So that's another plus for the mission. They're going to do research into health, using ultrasound to monitor, detect and quantify Venus gas emboli, or VGE, contributing to studies on human prevalence and to decompression sickness. Also gather data on the radiation environment to understand how space radiation affects human biological systems. They'll provide biological samples towards multi-omics, I don't understand that one, analysis for long-term biobank. Scott Petit will actually wear a neuro-ocular device, which will actually be in his skin, I believe, which is to monitor neuro-ocular syndrome, or SANS, a key risk to human health in long-duration spaceflight.
Yeah, Michael, that's going to be implanted into his next to his spine in the spinal fluid, so it'll be experiencing the same pressures as it is. Right. As the pressures that will be in his skull. So yeah, that's what he's doing.
Yeah, I wasn't sure exactly where it was. That's okay. The crew will also test the Starlink laser-based communications in space, providing valuable data for future space communications, for those necessary for missions to the Moon and Mars. So that's another test of new technology that they're going to do as well. So that's Polaris, the first Polaris Dawn. It seems there seems to be a lot to involved when they're actually only up there for about 5 days. So I think they'll be quite busy. So Polaris 2, I'm afraid there's not much detail on Polaris 2, other than that it will build on Polaris Dawn. There'll be another SpaceX Dragon, and it will carry 4 commercial astronauts, including Isaacman again. So it basically, it'll have taken the commander's seat again on that one. And that will be, I'm not sure how long we'll have to wait for that one, so I'll keep you informed on that.
Yeah.
And Polaris 3 is to be the first human spaceflight on the SpaceX Starship. The first fully reusable transportation system designed to carry crew and cargo to Earth orbit, the Moon, Mars, and beyond. Again, I think that's going to be a few years down the line, and depending on how they're getting on with the development of Starship.
Well, the thing is, I mean, once Starship starts flying regularly, presuming it does, it's going to be, how many flights will it have to do to get humans certified? So, yeah. I mean, some people have been saying it'll have to do 100 flights before it's even considered for being certified as fit for humans to travel in. So, as you said, it will be a few years down the line, I'm sure.
It'll be interesting when it comes, but it'll be. I'm afraid we'll have to wait for that one.
But you never know. I mean, the rate that SpaceX are working at the moment, like fury, you never know with SpaceX. So we'll see.
Yeah, okay. And that's about it. So thank you very much.
Great. Thank you very much, Michael, for that.
Just a bit of historical context. When you were talking at the very beginning about it's not linked to the Polaris missile, the ballistic missile project, just as a bit of context to that is the missile that we chose to go for delivery of our own nuclear deterrent. We gave up our Black Knight to actually go with the Polaris mission. So that was a dark day in the UK space industry. But I just thought I'd like to add that in there.
And that was when the UK government was told there's no future in space in space flight or human space flight at least. Yeah.
I mean, Andy put up. Sorry.
Yeah, I was going to say, there's a Daz and I were watching a fascinating episode of Tomorrow's World.
Yeah.
1964, was it? I think, Daz, somewhere around there.
Yeah, something like that. 64, 64.
Where the sainted Raymond Baxter was talking about the UK space program. But it was just after the French had launched their first rocket, and he was talking to a guy from Hawker Siddeley, if you remember them, about the UK space program, and the guy was saying, the government are not supporting it, and they're not giving the UK space program any money. And I think, God, here we are, 60 years later, and nothing much has. Well, it's changed now. Thank goodness the government is actually.
The other interesting bit about on the UK rockets, like the Blue Streak, which was launched in Australia, but it was actually launched a few days after the actual program was cancelled.
Yeah, that's right.
Yeah,
it was. And the man from Hawker Siddeley was quite interesting because he was obviously entering the "how much Brill cream can I put on my hair" competition. And I think he won. I think
he was sponsored by them.
But, everybody wore Brill cream in those. I was saying to Daz, I remember my dad was a broker in the city of London.
Yeah.
He used to go out of the door every morning in his yes.
There's Jonathan pretending. He needs Mr. Sheen, I think, not Brooklyn. Yeah. Mr. Sheen.
Barry. Barry now.
Anyway, back to the astronomy.
My dad used to go out in the morning in his bowler hat with his rolled umbrella. And he used to slaver the Brill cream on, but everybody did. It was what every man wore, even if they got hair or not. They still probably.
And it had that distinctive smell as well, didn't it?
I could really still smell that Brill cream.
Yeah.
Anyway, from Brill cream to astronomy in one leap. How about that? So Steve Warbis has been very kind to do a create a video for us, all about the summer sky. So we're going to play that now. So thank you very much, Steve. And here we go with Steve's video about the...
Hello, everyone. It's Steve Warbis here.
Right. Yes. Okay.
In this presentation, I'm going to show how...
And we have problems with the video. Okay.
Oh dear.
You can find your way around the summer sky, particularly using...
Right, we have a problem with this video. That's really strange because it was playing perfectly on my PC.
The three stars of the summer triangle, the large and prominent...
Okay. Well, Steve, dreadfully sorry about that. It was fine.
An asterism or pattern of stars in the summer sky.
Yeah, I think we'll have to come back to that, unfortunately, Steve, because this is really strange. Steve sent me the video, and it wouldn't.
I've watched it. Yeah,
it wouldn't play at all on my computer. Then he sent it to me again, and it was playing fine on my computer, but it's not playing here. Let's just try playing it one more time before we give up. No, it's completely...
To begin with, I'm going to use my all-sky map, which shows...
No, that's definitely not working. Sorry, Steve, you're going to have to look into that and get back to you on that. So apologies for that. Don't throw anything at the screen, please. We will get it. We will do it.
Would it be better if you upload it to YouTube itself, wouldn't it?
Yes, it might be, actually. It might be easier for that.
Yeah.
But I'll be in touch, Steve. We'll sort it out. Don't worry. But thank you so much for doing it. Okay. What have we got next on the agenda? Well, next on the agenda, last week you may know that there were two major astrophysical announcements on the same day as it happened, and they were completely unconnected. And it's not often you get two major announcements like this on the same day. We covered them both, of course, here live on Space Oddities because they were both important announcements. They are entirely unconnected. They're about two completely different things. One was about the gravitational wave background, and the other one was about the neutrino Milky Way. So what I'd like to do now is to talk you through exactly what these were all about. So just give me a second to sort myself out here. And here we are. So I hope you can see this. So the first bit is about the gravitational wave background. Now, let's start off by having a look at, if you like, the spectrum of gravitational waves. As you're probably aware by now, we have detected over 100 gravitational wave events since 2015 using the LIGO detectors in the United States and the Virgo detector in Italy. Now, here we have a scale showing you the frequency of the gravitational waves, what type of objects we can detect at those frequencies, and how we can detect them. So the first thing to say is that between the 1 and 100 hertz frequency, this is what we've been observing out at the moment, and this has enabled us to detect merging black holes, colliding neutron stars, collisions between neutron stars and black holes. And this is the limitation, if you can call it that, of the LIGO and Virgo detectors. They're observing in those sort of frequencies. So these are really quite high frequency observations. The instruments are tuned to detect gravitational waves at those frequencies. So these are high frequency, short wavelength, if you like, events. But there are other types of gravitational waves in the universe which are much lower frequency with a much longer wavelength. And in particular, we're talking about the merging of supermassive black holes at the hearts of galaxies. And this is right down here at 10 to the minus 8, 10 to the minus, well, between 10 to the minus 7 and 10 to the minus 9 hertz in frequency. These are much longer wavelength events. It's reckoned that some of these wavelengths could be light years long. And to detect these, one way of doing it is to use pulsars to detect these gravitational waves. Now, to do this, you use the thing is called the pulsar timing arrays. And astronomers have used millisecond pulsars for this. Now, what are these? These are pulsars that have got a rotation speed of less than 10 milliseconds. And we know their rotation speed incredibly accurately. They are the universe's most accurate clocks. They in terms of timing, they rival the most accurate atomic clocks that we have. The fastest spinning millisecond pulsar yet discovered rotates at an amazing 716 times per second. And they thought to spin at that speed because they've been accumulating material from a companion star, which has the effect of speeding up their rotation. But the important thing is here, they are incredibly accurate clocks. Now, astronomers have used 68 of these, all at different distances from the Earth. And as the pulsars spin, these lighthouse-like beams of electromagnetic radiation, be they X-rays or radio, flash in the direction of the Earth so that we can see them. Of course, this is greatly slowed down because these are millisecond pulsars. They're rotating once in less than 10 milliseconds. But I didn't manage to find an animation that would show you that rotation speed, funnily enough. So these are 68 pulsars at different distances from the Earth. And we know exactly, to an incredible accuracy, many, many, many decimal places, exactly how long they take to spin once. So what happens is that you have a gravitational wave which passes through the universe, and this has the effect of delaying or advancing the time at which the pulsars, the signals from these pulsars actually arrive. And by working out exactly how long these signals are advanced or delayed, you can learn something about the gravitational wave that has passed through the universe that has actually done that. Now, look at it another way. Here we have a graphic showing the Earth surrounded by these millisecond pulsars. Far off in the universe, as we know, there are galactic collisions between galaxies, where the two black holes, one in each galaxy, or in some cases more than two galaxies collide, in which case it'd be three, they come together and slowly begin to orbit each other at the center of the galactic merger. Now, they probably orbit each other for, many thousands of years, but they inexorably come closer together. And as they do, because they're accelerating around each other, they radiate gravitational waves, because anything that accelerates in the universe generates these gravitational waves. How do we know that this happens at the center of galactic clusters with these supermassive black holes? Well, we can actually see it. Here you have an X-ray image of the center of a galactic merger 400 million light years away, and you can see clearly here that there are two superheated disks of material showing up in X-rays, and if they weren't that hot, we wouldn't be able to see them in X-rays. And these two disks surround supermassive black holes. Now, to see the gap between those supermassive black holes at a distance of 400 million light years means that, of course, they're very far apart. Otherwise, we wouldn't stand a chance of being able to split those into two separate objects. Those two black holes are separated by 5,000 light years, believe it or not. That's the gap between the two you can see there. If we add the radio data into that graphic, we can see the jets of material that the black holes are firing out across the universe. And they are swept back, if you like, in this combined radio and X-ray image, because the black holes are plowing through the interstellar medium at about 1,200 kilometers a second. And this forces their jets to be swept back as if they were in a wind, if you like. So we know that we can see these black holes which one day will merge. And as they do get closer together, the gravitational waves from them get stronger and stronger. But the point is that they are very long wavelength, low frequency gravitational waves. Now, why would a pulsar either advance or retard the signal from a pulsar? So if you can imagine, you have a photon leaving a pulsar on its way towards the Earth. And because gravitational waves stretch and squeeze space-time, they stretch it in one direction, squeeze it in another, the photon will actually have to pass through a greater or longer distance, because space is either being stretched or squeezed. And this means that it will if it's being stretched, the photon will take longer to pass through the gravitational wave, because space is literally being stretched. So the photon takes a longer time to arrive at the Earth. So its arrival is delayed compared to when it should be arriving, because we know exactly when it should be arriving, because they are the universe's most accurate clocks. Similarly, if space is being squeezed, they arrive in advance of when they should arrive. Now, what astronomers have found is this, that there is a background noise in the universe of these gravitational waves, because gravitational waves, according to Einstein, and we have to say we think there are quantum reasons why this probably doesn't happen, but according to Einstein, gravitational waves never die out altogether. They just keep traveling forever. They get weaker, but they never die out altogether. So in the history of the universe, all of these mergers, and there have been probably countless mergers between supermassive black holes, all of these gravitational waves come together over time to form this background hum, if you like, of gravitational waves to the universe. And this is what they've now detected with the pulsar timing array. Now, it has to be said, first of all, that merging supermassive black holes is not the only explanation for this background hum in the universe. There are actually some quite exotic explanations that could be true, but obviously there will be more studies needed to determine exactly what the cause of this hum is. But the most likely candidate is these supermassive black holes. The project to do this, the pulsar timing array, has been running for 15 years. So they've had a chance to collect these long wavelength gravitational waves over 15 years, coming from all over the universe. And the whole point about it is, and the great thing about this is, that the pulsar timing array, well, it's not just one group of scientists. There have been similar experiments going on using pulsars, but using different pulsars in India and other places. And there are several groups that have now all come up with exactly the same results, that there is this background gravitational wave hum, if you like, to the universe, which means that the Earth is being bathed in these gravitational waves all the time. And everything on the Earth, including you, of course, including everything on the Earth, as well as the Earth itself, is being stretched and squeezed all the time by these gravitational waves. Now, you won't feel it, of course, because the difference in size of being stretched and squeezed is about 1,000th the diameter of a proton. But it is happening, and we now have the instrumentation to detect it. So over time, all of these gravitational waves coming from all over the sky merge into this background that is now being detected by the pulsar timing array. For the future, this is fantastic, because what they hope to be able to do is to actually pin down where these gravitational waves come from, what types of objects are producing them. But as I said, it's more likely than not to be merging supermassive black holes. The International Pulsar Timing Array, these are the locations of the telescopes. We have, it includes the biggest radio telescope in the world, the FAST telescope in China. We've got the famous Lovell telescope at Jodrell Bank, of course, in the UK. We've got the Chime telescope in Canada. Arecibo, before its unfortunate demise, was taking part. We've got Meerkat in South Africa, which is a precursor telescope to the world's biggest radio telescope, the Square Kilometre Array, which will be complete hopefully before the end of the decade, although it might be a little bit delayed because of COVID. We've got the famous Parkes Radio Telescope in Australia, and we've got a couple of others. But, there have been several groups of scientists working on this and asking the same questions, and they've all got exactly the same results. In fact, the different teams coordinated about when this was going to be released last week, so that nobody was scooped. And there's just some of the telescopes involved. The Jodrell Bank, of course, at bottom right, the Chime telescope above it, and so on and so forth. So that was the announcement. We finally detected this gravitational wave background in the universe, and the future for gravitational wave astronomy, which is, let's not forget, only 8 years old as a science, it's already detected this. And this science of gravitational wave astronomy, the first time we've been able to observe the universe in anything other than light electromagnetic radiation, has advanced amazingly in 8 years. And the two LIGO detectors, or the three LIGO detectors, I should say, the two LIGOs in America and the Virgo detector in Europe are now back online, working together. They came online the last week of May, and they have made lots of detections already. I was looking the other day, one day in particular, they made 9 detections of gravitational wave results yet to be analysed. But, even if half of them are terrestrial in origin, something vibrating on the Earth rather than the vibrations coming from space, then, the upgrades that they've undergone over the last couple of years will be well worth it. So we're all really excited about the future of this fledgling science of gravitational wave astronomy. Okay, now let's talk about the other announcements, which came an hour later. So we had to rally around and get things organised to cover them both. The Milky Way in neutrinos. What you are looking at is IceCube. This is an observatory at Amundsen Station at the South Pole in the middle of the Antarctic continent. Now, it doesn't look like a conventional observatory, because where are the telescopes? Well, it doesn't have any telescopes. It actually doesn't look upwards at all. It looks downwards. What is this all about? So if you look at top left of this graphic, there's the laboratory sitting on the surface of the ice. And underneath the ice, they have dropped 86 strings, if you like, cables, with a total of 5,160 optical sensors. What on earth is this all about? And they go down a long way as well. You can see on the right the height compared to the Eiffel Tower. Now, they're there to detect neutrinos. These ghostly particles, which are very mysterious, coming from the depths of space. They're very difficult to detect because neutrinos pass through matter as if it just weren't there. It's often said that a single neutrino could pass through a sheet of lead 30 light years thick and not even notice it. So they are very difficult to detect because they don't interact with ordinary matter. But occasionally they do. And this immense detector, the Ice Cube laboratory at the South Pole, which was built over quite a few years, because as you can imagine, drilling all those holes that far down in the ice, 2,820 meters down in the ice, and lowering all those 5,000 odd detectors was a huge job. When a neutrino passes through the ice, occasionally it does collide with an atom, and that produces a very faint flash of blue light called Cherenkov radiation. And this, as you can see on the left, these DOMs, these digital optical modules, these are basically light detectors that can detect those tiny flashes of light. And by working out where they were detected, they can work out the path of the neutrino. Now, the detector is not just useful for detecting neutrinos, it's also useful to detecting cosmic rays. And here we have a graphic showing you Ice Cube, as it says, the downward-looking telescope, because these neutrinos have passed through the Earth before coming out of the ground at the South Pole. But the detector is also useful for looking at cosmic rays. And as cosmic rays hit the atmosphere, they decay into particles called muons, which pass through the detector. So they've spent a long time working out exactly where these neutrinos are coming from. They come from all directions, of course, but a lot of them come straight through the Earth to the detector at the South Pole. And in actual fact, here's an example of a muon passing through the detector. As it passes through, you will see the blue lines. This is actual data, which represent the Cherenkov radiation that's given off. And this is a path of a muon, one of the shower that result when a cosmic ray decays in the upper atmosphere. And as you can see, they can work out exactly where it came from on the sky because of its path. So what is this all about, really? Well, what it's all about is the Milky Way. So here's our galaxy in optical. In optical light, that's what our galaxy looks like. You're probably familiar with something like that. If we look at it in radio waves, that's what the plane of our galaxy looks like in radio waves. This is what it looks like in high energy gamma rays. But now we can add to that. We can show you what the plane of the galaxy looks like in neutrinos. And it looks like that. So this is the first time that we've been able to map the plane of the galaxy using neutrinos. It's an immense achievement. There are lots of bright neutrino sources there. The next step will be to work out where those neutrinos are coming from. Neutrinos are created basically every time two atoms collide, it releases neutrinos. So this is typically in the hearts of stars, in thermonuclear reactions in stars. Neutrinos are also produced in supernovae explosions in large numbers. And basically, anytime two atoms collide, then they release neutrinos. Another way of looking at the same thing, just putting some more visible graphics on the galactic center and the galactic plane. As you can see, there are lots of neutrino sources there. So astronomers will now be trying to work out what is producing those neutrinos. So again, like the gravitational wave announcement, very, very big step forward for Ice Cube and neutrino science. congratulations to both the Pulsar timing array and the Ice Cube team for 2 incredible announcements last week. And just to finish, I'd like to read this. It's a poem by, of all people, John Updike, who chose to write about neutrinos, and it's called Cosmic Gall. Neutrinos, they are very small. They have no charge and have no mass and do not interact at all. The Earth is just a silly ball to them through which they simply pass like dustmaids down a draughty hall, or photons through a sheet of glass. They snub the most exquisite gas, ignore the most substantial wall, cold shoulder steel and sounding brass, insult the stallion in his stall, and, scorning barriers of class, infiltrate you and me like tall and painless guillotines. They fall down through our heads into the grass. At night they enter at Nepal and pierce the lover and his lass from underneath the bed. You call it wonderful, I call it crass. So there you are. So that's John Updike on neutrinos, and I think that's a wonderful poem. So there we are. So that's what happened last week, guys, and it was quite an incredible week last week. Any comments? No, you're stunned, are you? Okay.
Excellent. Thank you, Andy. Excellent.
So yeah, it was an exciting week last week. We knew about the gravitational announcement really before it happened, because they actually released the scientific papers the day before, so that they all of the international teams have been working on this. They all released their papers at the same time, so one team didn't scoop the other, if you like. So there we are. So that was an interesting time, but we had no idea what the neutrino announcement.
Yeah, it's like waiting for buses, wasn't it, last week?
Yeah, it was. Yeah, absolutely like that. So there you are.
Oh,
okay. So we go over now to Jonathan, who's going to tell us a little bit about the Tunguska event.
Okie dokes, no problem at all. Thank you very much indeed, Andy. Well, of course, the end of June this year saw the 115th anniversary of the Tunguska event. It was June the 30th, 1908, when the largest asteroid impact in recorded history struck on a warm summer morning in Siberia, Russia. It struck in the Tunguska River Valley area of Siberia. It's a sparsely populated northern forest land in that area. Witnesses, according to eyewitness accounts of the day, reported seeing a fireball of bluish light, nearly as bright as the sun, moving across the sky. The asteroid was traveling at the speed of around about 33,500 miles per hour. That's 54,000 kilometers per hour. And it is believed that it exploded around about 6 miles above the Earth's surface. Now, estimates on the size and composition vary greatly. There's a lot of debate about the actual size, but the sort of average line on this appears to be that it was 130 feet in diameter, stony in composition, although I've seen a recent report that actually now claims that it was more of an icy sort of body. And that's very important because it actually tells us exactly where it originated from, but I'll talk about that more in a minute. And the entry angle, because of the eyewitness accounts, seemed to put it at around about 30 degrees. That's based on the trail across the sky. Now, observers at the time accounted as seeing a flash, the sound similar to artillery fire, and moreover, a very powerful shockwave broke windows at a considerable distance. It disintegrated at high altitude, the remains of which are what was left of the main projectile, exploding into showers of bursting debris. And as it did so, it leveled everything within its path. And the area that the actual explosion took account for was around about 830 square miles. That's 2,150 square kilometers. It managed to fell 80 million trees in that area. Everything was swiped, if you like matchsticks, leveled when the explosion occurred. Now, the trees were scorched rather than burned, as the initial flames from the descending object lit them with the trailing passage of wind, then quickly extinguished any flames. So rather than being burnt, it was more of a scorched sort of scenario with the wind taking out the sort of burned. Now, as the Earth shook, windows smashed. They believe something in a region of 60 to 100 kilometers distant from the sonic boom. Now, as to how it happened, many theories abound on this one. But one of the most interesting ones about where the actual asteroid originated from was what appears to be a rather cosmic game of billiards that took place in the asteroid belt, where there was now we know in the asteroid belt there are plenty of collisions taking place all of the time, and pushing asteroids off into various different orbits that may account for a lot of the moons that we see, although the smaller moons orbiting some of the planets. But it looks like one of the most intriguing theories is that it was rather like a snooker action or a billiard action where two asteroids hit each other, and the one asteroid actually skewed off, and it was a direct hit on Earth. Now, the chances of that happening are absolutely astronomical, of it happening again. But that's one of the more intriguing theories, that it did actually originate from the asteroid belt. We got this one asteroid striking another, and for some unknown reason, and unfortunate really for us, it actually headed towards Earth. There's the region it hit in Siberia. Now, the impact, thankfully, was a sparsely populated area, just a number of small settlements in what was a chiefly wooded landscape. However, one death was reported, that of a local deer herder who was thrown into the side of a tree following the blast. There's also been a report of another one, an old man dying of shock at the time, but it did wipe out reindeer, plenty of wildlife killed. And right across Europe, over a sequence of nights following the actual explosion itself, from June the 30th onwards, there was a nighttime glow which was seen, a sort of visual reminder of what had transpired on the morning of June the 5th. So sort of remnants of that. Now, nearer to the impact, let's close in on the impact site itself. The reports emerged of people being physically knocked to the ground. That chap, of course, unfortunately losing his life, physically knocked against a tree, and one person being felled into a state of unconsciousness. And this particular chap, there's another report that came in. This one particular fella, he woke several days later to find that all around him was not as it was when he actually fell over. Also, people being singed, if you like, by the intensity of the blast itself. Again, not being burned, but singed because of the following wind that came behind it. Now, the blast equivalent of the Tunguska event is in line with the explosion of around about 185 times more energy than Hiroshima created. Wow. And if the Tunguska fireball had occurred in a densely populated area, the devastation obviously would have been absolutely horrific. That's what it did to the trees in the surrounding area. Of course, it took care of around about, they think, 80 million trees felled in a sort of one fell swoop by this. Now, we did have a later incident, of course, the Chelyabinsk in Russia. That took place on February the 15th, 2013. A similar, smaller airburst occurred over the city of Chelyabinsk, Russia. That's 1,500 miles to the west of Tunguska, which is rather strange, really. People say lightning striking twice in the same area, but that's rather strange to have it striking in such a small area. If you look at that sort of area there, just 1,500 miles apart. Now, since the actual event took place, it has been now observed as Asteroid Day on June the 30th, the anniversary, of course, of the Tunguska explosion itself. But again, two real things remain unresolved. I think the debate will rumble on about this, is the actual where it actually originated from, which I firmly believe was a freak incident in the asteroid belt that actually hurled an asteroid our way. Now, statistically speaking, you would have thought asteroids are flung out all over the place, so it had to be at some point, if you just work the averages, that one day one would head our way. But to head that way at that speed, at that time, to hit Earth, which was just a pinprick on the horizon, that's quite extraordinary. And to see and to ask whether or not it could happen again, well, of course, yes, it could happen again, but the odds again are greatly stacked of having a similar incident taking place. So that's one of the big debating arguments as to where it originated from, and secondly, as to its composition. It would appear to be that the majority that it's a stony asteroid, which would probably place it more in the asteroid belt than sort of further afield where it was an icy body. And again, I know I've been criticised maybe for saying that it's doom laden and neo watched, but it just goes to show exactly what can happen should we get one of these strikes, and were it to fall in a populated area. We run that risk constantly. But I'm looking at this now and what happened in 1908 and then again in 2013, it just goes to show that I mean, Shoemaker-Levy, that also proved a point, although obviously Jupiter a much larger target. But then again, though, having been hit as such a small pinprick on the horizon as Earth is, then it just goes to show that that possibility still exists. And luckily enough, the way in which things are at the moment, with the way in which we are scanning the skies, we are keeping more of a watchful eye on things, which leads you on to another debate as to whether or not we're doing enough at the moment to sort of take care of what we really need to be looking out for. Because as far as I can see, it'll boil down to two things. And that's one, that our own self-destruction, it'll come from within. We are the custodians. Let's give you an idea of the actual Tunguska area, and were it to strike Washington.
Wow.
I'm sure there's a UK comparison to that, but that's what it would wipe out. So the two, it's going to be either us as current custodians looking after ourselves and sort of self-destruct, letting the sun doing its natural thing and absorbing us at some point, or a strike from outer space, which I would have, or inner space, which I thought is probably something that we're still not addressing on the scale which we should. But the 30th of June now marking International Asteroid Day, and a timely reminder of what can happen if we're at the mercy of the skies.
Right. Yeah, indeed. Thank you so much, Jonathan. That's brilliant.
Yeah, thank you.
There was quite a lot of disagreement for many years about whether the object was an asteroid or the nucleus of a comet. Do you know? Has that been resolved now? Firmly in favour?
No, it seems to be a composition of stony asteroid. That appears to be it. I mean, if you're talking about an icy layer there, then you probably could go for the remnants of maybe a cometary body or the core of a cometary body. But the search turns up so many. And searches were carried out into the actual crater itself, and nothing there was fully revealing about the actual composition. So it does remain a mystery. My money is on an asteroid, and it was a collision that took place.
There was no actual crater, was there? And this is why people said it was a comet, because it had vaporized above the ground.
6 miles above.
The surface.
So
because I can remember seeing films. Sorry, I can remember seeing films of the expeditions that they sent in to try and find out what it was, and the thing was that they were hindered by absolutely being attacked by millions and millions of mosquitoes. So in the end, they had to basically get out of there ASAP because they were being sucked dry by these millions of mosquitoes. It wasn't a very nice area for it to happen.
But is it remarkable though that just like in 2013 you get a strike in that area, just 1,500 miles away from Tunguska. It's uncommon that you have two major strikes within that sort of a space radius.
And of course, if it had arrived either an hour earlier or an hour later, it may well have hit a major population centre.
Absolutely.
The timing was amazing.
It could be just minutes. It could be just minutes that make that difference. But of course, we have been. I mean, all over the sea. struck before. So loads of times since we've had satellite observations of the Earth, we've had these some of them very large craters. Of course, they're all weathered and things like that because we have weathering on this country. But of course, the Arizona crater, can't think of the name of it now.
You mean
the Arizona meteor crater? Believe it or not.
Meteor
What? Sorry.
Meteor crater.
Yeah, it's actually just known as the Arizona meteor crater.
Oh, I get it.
The one next to the
just lucky it landed right next to that visitor center, wasn't it? But yeah, it's yeah. So yeah, we've been struck several times before in the past. Barringer, yes, thank you, Ian, and Kev.
Of course.
Barringer crater. Yeah, sorry, yeah. But yeah, it's I mean, of course, they actually use that for the Apollo training of the astronauts. So yeah, we digress.
We do. There we are then. So thank you for that, Jonathan.
Welcome.
As you said, it is sobering, food for thought. Because it could happen at any time, and that is no exaggeration. And efforts continue to try and map all of these near Earth objects to find out which ones are.
These things happen, Derek.
All we can do is two things. We need to do. We need to continue with mapping them, but we need to take, as I'm sure Jonathan would agree, we need to get governments to take this threat more seriously than they do. Because as ever, governments only think 4 years in advance. They think, well, it's not likely to happen while we're in power, so why should we care? But for the future of people on this planet, it's an issue that needs to be taken a lot more seriously than it is.
Yeah, because I can remember asking Jonathan quite a while back is whether or not the UK have any plans for if anything like this was going to happen. I know the Americans have, and I was going back over their plans the other day. I came across them. It makes interesting reading because it goes from sort of like how you're going to try and deflect it, do what you can to try and deflect it or whatever you're going to do. If you're unsuccessful or you haven't got enough notice, how you're going to notify the population and contingency plans for when it happens. When you get an ELI event, Earth Life Extinction event, there's not a lot you can do about it. It's just basically kiss your ass goodbye. So it's
I think that it's with regards to that, it'd probably be a contingency plan not to let anybody know. That we'll know soon enough if it from a strike, because there really is nothing up there at the moment. And you were talking about the deflection. It appears to be the most favourable way of dealing with it. Although I've seen that the space tractors, which is getting a probe up there to actually pull it off its course. It's a direct hit to smash it. But it's just a different plan of action. That's all we're asking for is that how you can deal with this rather than what we're going to do about it. Well, let's put something on the table. Let's get our heads together on this and bump it up the agenda somewhat. And let's take a look at that. Never mind about. I know Mars is a lovely thing to look at and to move on to, but I think we've got to make sure that we are ourselves are properly defended in that case, and we are light years away from getting to any point where we can deal with it. I can tell you, there are lots of plans on the table. There are lots of speculation and conjecture, but it's just not good enough. It's just not enough. You think, oh yeah, well, we'll leave that because the naivety of it all is they believe it will never happen. And yet 1908 and 2013, there you go. What more proof do you want? And as Dad said, you've got satellites turning up various craters, the Antarctic and the Arctic itself. Explorations there have shown huge impact craters all over the place. What more evidence do you want to take action?
Absolutely. Well, when you think that at Chelyabinsk more than 1,000 people were injured, mainly by flying glass.
Yeah. Yeah, they were all watching out the windows and when their glasses came in.
Yeah, which is, in retrospect, probably not a good idea.
Yeah.
Well, thank you, Jonathan. Fascinating topic,
yeah.
one I'm sure we'll return to in the future more than once. Okay, well, we're going to start wrapping things up. Before we go, we'd like to say a big thank you to Rother Valley Optics for supporting us in our little venture of Space Oddities. Just to let you know something quite interesting, Rother Valley Optics have come up with a cunning plan, and this is it. It's motorhoming under the stars. And what you can do, you can hire from Rother Valley Optics this amazing, just let me go to here, motorhome. And they will actually drive it to one of 3 dark sky sites for you. It's all kitted out. It's kitted out with a telescope and all sky camera, and it's a luxury roller team Pegasus 740. That must mean something to somebody, I'm sure. It's fully equipped. Look, it looks really, really nice inside. And they said that they've got the right equipment for you. They will drive it for you so that you can use it to drive around at dark sky locations. And the 3 motorhome locations are in Kellingheath and Kielder Forest and Ravenshill, all of which are registered dark sky sanctuaries, if you like. And there you are. So if you would like to look into that, to plan your holiday in dark sky sites, you can email them at, I think the email address we have is sales@rothervalleyoptics.co.uk, or you can call them on 01909774369. That's 01909774369. I will put those in the description of this video. And it just seems a great way to plan your holiday with a luxury motorhome kitted out with astronomical equipment. Yeah. So there you are. So just bear that in mind for your dark sky holidays. Okay, we are going to bring things to a close for today. I would like to thank everybody here for taking part. Thank you, Jonathan. Thank you, Michael. Thank you, Roger, who did his first freestyle gallery tonight. So well done. Thanks, Daz, as well. We are Space Oddities. We will be back this time, or 8 o'clock UK, next week with even more fun and frolics, if you can bear the suspense. Thank you very much to all of you who bought us a coffee. Thank you for your general support. We've really enjoyed having you as viewers, and we'll continue to do so. If you'd like to get in touch with us at any time about anything, just email us at spaceodditieslive@gmail.com. Very, very easy address.
Yeah, just a quick one, Andy. Also, thank you to everybody who's ordered T-shirts and hoodies. I saw them scrolling down through the chat. So thank you very much. That's very very generous.
Oh, great. Thank you very much. Yeah. We hope you enjoy wearing them and spreading the word about Space Oddities. So there you are. Yes, you're going to look very cool, and you will be the envy of people on your road, I'm sure. All right then, guys. Thank you so much for watching. We've been Space Oddities. We'll see you again next Monday. And don't forget, keep an eye on the channel, because we're always posting new videos and things on the channel. And we've started a new playlist on the channel, which you may have seen, called Space Bites, where we cut out bits of these Monday shows, just short bits, and put them in the playlist called Space Bites if you haven't got time to watch all of the shows. So I'm slowly uploading those. We've got some other stuff coming up shortly as well. Daz has actually posted a new video that he's done, which is really, really good, about the link between sunspots and earthquakes and volcanic eruptions, and that's on the channel. It's in the other videos playlist on the channel, and we hope you enjoy watching that, because it's really interesting. Because we were saying when Daz was talking about it that we would never have suspected a link between sunspots and earthquakes and volcanoes, but there is one, or potential one, or more than one. So there you are. So you watch Daz's video, because it's really good. And I'll have the £5 now, please, Daz. Okay, right. Jonathan's got
Well, it's just a shame we didn't.
Look at Mr. Cash here. Look at that. Yeah. All right. Yeah. I'm not paying.
It's just a shame Lou wasn't here because what he was going to talk about sort of like linked in well.
Yeah.
So
Apologies,
yeah, it would have linked in well.
There you go, Dad's 20.
Yeah.
Cheers, mate. Cheers, mate.
You're very welcome.
Go some 20.
Apologies again, viewers, that Lou wasn't here tonight to deliver his presentation about the sun and the weird behaviour that we're seeing from it at the moment. But we'll try and get that arranged for next week. All right.
Use the sound graphic for next week.
Yeah, absolutely. Okay, then. Take care, guys. We'll see you next Monday. Say goodbye, guys.
Goodbye, guys.
Bye, guys.
Bye, guys.